Hello everyone. Welcome to Kopernik Observatory and Science Center. My name is Jeremy Carty. I'm a science educator here at Kopernik. And today we have an excellent program updating you on the latest on James Webb and Artemis 1. But before we jump to that, I just want to mention a few of our upcoming programs and some ways that you can interact with us online as well. I'll jump on here quick for a moment. Here's our webpage, kopernik.org. If you've been to Kopernik before, you may be very familiar with this. We list all of our upcoming programs. So here's tonight's James Webb and Artemis update. So welcome everyone. And then we also have an online stream coming up to cover the conjunction of the Moon and Mars. And this will also turn into an occultation of Mars. So I'll discuss that when we jump to the YouTube page in just a moment, because that's how you'll get access to that event. Also coming up, we have our Holiday Horizons, and this is a family event for targeted at students in grades K through 5. But I think there's a lot of fun to be had for those younger and older. We have activities planned. You make a Saturn ornament. We have holiday light circuit experiments. A planetarium show, which you may have seen our planetarium in the lobby. We've been prepping for the planetarium program, where you'll get to explore the night skies at the North Pole and see how they behave differently to the skies we have here in New York. So you have a couple Saturdays to choose from there. You have December 10th and December 17th. Excuse me, and then 2 sessions each day. So you can either register for 5 p.m. or 6:30 p.m. and you'll be up here for about an hour and a half, enjoying all the programs that we have available. Also, if the skies are clear, we'll be going outside to the observatory and looking at some of the planets that are out there. There's also this object called the Christmas Tree Star Cluster, which is a mix of a nebula and a star cluster, and together it kind of looks like a lit Christmas tree. So kind of a neat object, very relevant to the theme of the program. So we'll be looking through our scopes. And you can buy tickets online. If you visit our webpage, there's a link to where you can register. Oh, and we're also doing a Orion ornament giveaway, which is relevant to our discussion on Artemis today. Every family will receive a mini Orion ornament. These are all 3D printed, by the way. And then we'll also be raffling off a larger painted, almost replica model ornament of the Orion spacecraft. So you'll learn more about that today. Okay, so that's Holiday Horizons. Also, I always like to come down to the clear sky chart. Oh, and let me switch this over for those that are on the stream so that they can see what we're looking at. There we go. We do have some viewers online, so we want to make sure that they can see what we have programming-wise. Here's our clear sky chart. This is a great place to go if you're interested in seeing whether maybe coming up on Holiday Horizons are the skies going to be clear. You can have a look here. Basically what you want to see is dark blue across the board. That is the ideal. And as you go lighter and then into white, the conditions would be getting worse. So tonight's a little bit iffy. Earlier on, it was clearer. But as the night goes by, it seems like it will cloud up a bit, and was cloudy last I heard. So we'll see. We have one of our telescopes set up. So if we're able to observe, we'll get you out there and looking at the planets. But coming up, you see these dark blues over here. Like Sunday night is looking pretty decent. So, all right. Then I want to lastly mention the Kopernik Observatory YouTube channel. Like I said, we have that coverage on the Mars-Moon conjunction. And of course, in real space, in 3D space, these objects are nowhere near each other. But in our sky, they will appear to get extremely close. And in our area, Mars will in fact go behind the Moon for about a almost half-hour period. So it'll disappear, you'll lose that red planet in the sky, and then it will reappear as it crosses the southern region of the Moon. So that'll be a really neat opportunity to see those objects at the same time. You'll see the surface detail on the Moon and the surface detail of Mars all at once in a telescope. And the way we're reaching out to you for this event is on YouTube. We've done a number of night sky live streams. And here it is. I'll bring it up here on this page. So conjunction of the Moon and Mars. This is a rough estimate of what it will look like through a telescope. And you can really see the size, the apparent size difference. But again, of course, that's just because Mars is so far away. Mars is actually much larger than the Moon. So December 7th, we're starting the stream at 6 p.m. You can join us on YouTube. And if you want to chat with us, you can do so and ask questions. That's what we're here for. We'll answer those questions on the stream itself. You'll see an image of one of our astronomers here. And then you'll get a telescopic view of Mars and the Moon. And we'll also do a wide shot, so you can see Mars approach the Moon and disappear. So we'll give you a couple different perspectives on this event. It'll be pretty exciting. The actual occultation starts at around 10:30 p.m. But what's also neat about this is that the following day, Mars is the closest to Earth it can be. It's at opposition. It's on a close approach. So it's also just a great time to observe Mars. So we're going to commit time and start the stream early so that we can take a look at that.
It's 39 million miles. Okay.
Yes, yeah.
Don't worry, it's not going to get close.
Yeah, we won't hit the Moon. But last thing I'll show you here, just kind of neat. If I refresh the page, you'll see we are streaming tonight's program on James Webb and Artemis live. We have 23 people tuning in according to this slide here. So we'll chat with them. I'll be back here on the live stream chatting, and we'll get some questions from them, and hopefully you'll have some questions too at the end of the show. But with that said, I'd like to pass this off to one of our other science educators, Tish, and she'll give this program.
Yay. All right, let's go. Did you catch the pictures that were up on the screen? All right, let's get back to it. Okay. Am I going to need to minimize this?
You can, yeah.
I wanted to get there anyway. Okay. I'm representing NASA tonight as a Solar System Ambassador for New York, and that means that they send me material and I share it with you. So all the public is welcome to ask questions, and I'll do the best I can to answer the questions. But I also want to point out that I am not an astrophysicist. I'm a science teacher who left middle school and came to Kopernik, and I fell in love with the night sky. And because of that, I've been here 21 years. And so after you retire, you could actually take my job. I mean, it's a wonderful thing to be able to work anytime you want and have so much fun. You can say yes or no to all the programs that we do, but we have so much fun exploring new things up here at Kopernik. It's always a busy place. So I want to mention, have you ever heard of this phrase, on the shoulders of giants? Well, we are so lucky right now to be in a place in space and in time when it's peaceful here in America. We have enough money and we can go to the moon. We can go, and after that, we can go to Mars, and we can explore deep space with a telescope that's never been bettered. It's called the James Webb Space Telescope. It's 1 million miles from the moon. But we're really lucky that right now we can do this. And we're just delighted that you guys are interested in it. One person that I've learned, one of the giants that I've learned from, is Dr. John Mather from the Goddard Space Flight Center and the Space Telescope Science Institute. They're the ones that are running the James Webb. And I'd just like to give you a little sample of him. Let's see how this works.
And you can't see it.
This is
anyway,
John
we
talking.
need the same
Listen.
sensitivity in space
Can you hear
to
that
see
okay?
astronomical objects that are cool. So these, what we see here is called the Southern Ring Planetary Nebula, and we've just shown you the magnified inner zone of it. This is a debris cloud that's coming out from a star that's old, and it's letting its material fly off into space. So, third reason, why do you want to study infrared? Because space expands. The universe is expanding, the distant objects are running away from us. It means that the wavelengths that we get are longer than they were when they were sent out. They get stretched along the way. So we actually use that to tell us not only one, is the space is expanding and distant objects are going away, but we can use this as a calculator to say, well, if we know how fast they're going, then how far away are they really? So we do that on purpose. So we start off, we take a picture of something, and we try to imagine what it would be like if it were actually at greater distance. Now, we had a movie. Now, okay, it's working. You see, they've animated the
He's
idea
talking to a
that
large group
the
of
galaxy will
people
look
at the
redder
Smithsonian.
if it's farther away. So just let me now begin to show you some of the pictures we actually took.
We're just going to look at one
This is the one
picture.
that President Biden
This one.
released on July 11th. It is a very long exposure of a single spot in the sky. And so it was observed with our near-infrared camera. Near-infrared camera covering from 0.6 microns wavelength, which is red, and you could see it out to about 5 microns, which you can't see. And what we see in here are a lot of beautiful things. The thing that might look beautiful to you is that star right in the middle with the 6 spikes sticking out. The 6 spikes are just the result of diffraction of light. Light is a wave, it bends around corners, and that's the pattern that we get from the hexagons that the Webb telescope has. What else have we got in the picture? We have a really big, bright, glowing region in the center, which is a gigantic, very massive galaxy, and it's got several other massive galaxy friends with it. They're pretty far away, but not really, really far away, and they are so massive that they can bend the light of more distant objects. So we're using this as another lens for the telescope. Einstein told us this could happen. He thought we would never find it. But we did. Actually, it was one of the first tests of relativity that the gravity of the sun was able to bend the light of a distant star just a tiny, tiny bit. But this other effect, where you could use it to actually magnify something far away, people guessed, but no, it was obviously impossible to ever happen. But nature does it for us. We have hundreds of these things in the catalog, places where we can look. So in the middle,
We're going to ask you to watch for his link in this program, and I'm going to minimize it. There we go. Here's the link, and anyone who wants to see the whole program right here. So John Mather won a Nobel Prize for his work in astrophysics, and he follows along and proves Einstein to be right and sometimes not right. And we're going to move ahead to some other experts. Here we go. Oh, I forgot to mention. See this orange bar? We're also going to go see Artemis and our moon. What's up? All right. Everybody asks us, where is the James Webb? And right now, this is a pretty good map, okay? Here's the sun. This is the Lagrange point 1 and the Lagrange point 2. Notice how they are in a straight line from the sun right through the Earth. And then it's on this halo-shaped orbit that looks vertical. And so it will follow the Earth and stay in the shadow of the Earth so it doesn't get overheated. So it's going to stay there. And I got a little nervous myself when I was thinking of, we just shot Artemis to the moon, right? And it's on the back of the moon too. I thought, I wonder if they're going to get close to each other, but no, not to worry. The James Webb is 1 million miles out and much farther away than the Artemis mission. Okay. There it is. We want to mention thanks to the Chandra X-ray telescope people from Boston. They gave us these giant posters that are back there on the table, and they added some X-ray to these James Webb images. Does anybody know the name of this one? I'll give you a hint. There's a 3D model of it in the front. It has 5 galaxies. It's Stephan's quintet. You knew that, yes. Stephan's quintet. And they added some violet and extra lot of blue here to show where the highest energy is. Notice right between these two galaxies that are converging, there is a huge amount of energy going on here. So we have an idea that it could be building a quasar or a black hole at that point. And this one is, anyone know what this is? Well, what is it called when you put your hands on the floor and you flop your legs over? A cartwheel, right? It's the cartwheel galaxy. And this one is famous for having galaxies go right through it and leaving a big hole behind. But there's a tremendous amount of energy everywhere where you see the purple, violet colors. Of course, this one is the image that we just heard from Dr. John. He did not see this cloud, though. That was before we added the X-ray cloud. And this is an indication of dark matter. Any place where there's this many galaxies together, there's so much mass, we think this is probably dark matter. Then, of course, what's this? Anyone? It's the beautiful, what? No, not that one. I will show it to you later, though. No, this is Carina. This is the Carina Nebula. Oh, I'm so glad that you don't know this yet because I'm going to talk about it a little bit. Okay. Let's move on. A friend of ours, Michelle Thaler, is a PhD in astrophysics, and she wanted to show you a little something about why should we use infrared in this camera. Here's a quickie.
These days we're all familiar with night vision cameras, but how do these things work? How is it that you can just turn on this camera and see the invisible? Another use of night vision cameras that you might not be familiar with is their ability to see through smoke and dust. Fire departments commonly use cameras like these to find people trapped in smoky rooms or to pinpoint the exact location of forest fires through clouds of smoke. So how do these things actually work? What are we really seeing when we look inside a night vision camera? Well, it may surprise you to learn that everything in the universe emits some kind of light. It's just not the kind of light we're used to thinking about. The sun, for example, our star, emits visible light. That's why our eyes evolved to detect that kind of light. But that's not the whole story. I'm sure you're familiar with all the different kinds of visible light, all the colors from violet to red. But there are actually lots of other kinds of light that our eyes aren't sensitive to. The reason all the colors of light are different is that they have different energies. And which
I'm going to pause it right there. Everybody who's got glasses and interns, can we turn the lights off? A normal little flame. Got a pair of glasses? We want to thank the Rainbow Symphony people for donating these. Okay. So, hello. Yep, camera found me, okay. Everybody got one? Okay, we're going to do a little experiment. A basic flame. Can we get this off? We don't want everything off, yeah. As a matter of fact, I'm going to stand over here just to confuse this camera. Okay, take a look with your glasses. You see a basic rainbow? Red, orange, yellow, green, blue, indigo, violet. How you doing? You got them all? Okay, and then it's magnified by how many times? I mean, how many are in that circle? All right, good for you. Okay, so there might be 8 in a circle. There might be 24, depending on the glasses you're wearing. But those diffraction gratings help us to simulate what we do with the spectra that we're going to be studying right now. You can rest your eyes for a moment. The same light that we had a minute ago. Are we all set? We need a little bit of light in the room. A little bit. let's finish Michelle's talk. Here we go. Right.
You see here is that the light has different wavelengths. The blue light, for example, has a higher energy, so it has a shorter wavelength. The red light, on the other hand, has less energy, so it has a longer wavelength. But that's just the light we can see with our eyes. That's not all there is. The shortest wavelength light are gamma rays, which can have wavelengths smaller than an atom. The longest wavelengths are radio waves, which can have wavelengths larger than the entire Earth. The kind of light an object emits depends on its temperature. We're used to thinking of something hot giving off light. But it might surprise you to learn that objects that are cooler, like myself, give off a kind of light too, and that's what a night vision camera can pick up. That sort of light is called infrared light. The world sure looks a lot different in infrared light. Remember that what you're actually seeing is temperature, so something that's warm is going to look bright in the infrared. And something that's cold looks dark. Ice cream. Blow dryer. And infrared radiation is actually a measurement of temperature. Places on my face that are cold, like my nose, appear dark in an infrared camera because they're giving off less infrared radiation. And places that are warm, like my mouth, or the hair next to my head, are brighter because they're warmer. You can even see my breath in my nose if you look carefully. And this is an ice cube.
Okay, Michelle. Pause. So, we can't do infrared without seeing Michelle Fowler. She's just cool. She's been doing infrared technology since she worked in California at the Jet Propulsion Lab. So anyway, she's now at the Goddard Space Flight Center, and we wish her well. She's a great teacher. Okay, moving on. Now, the James Webb Telescope, if you look carefully, is going to cover this part of the spectrum, the near infrared to the far infrared, and not quite into the really far infrared. The infrared turns out to be a very large, wide span. But the Hubble could only go this far into infrared, and it's frankly running out of gas. It's batteries, it's all kinds of parts are not working as well as they should. It's 30 years old, okay, so it's time for it to come home, and when it comes splashing down, we're all going to know about it. The Spitzer infrared telescope lost its coolant, and so it cannot work properly anymore. A few times we get a picture from there, but it's not that accurate anymore. But it did great things in the past. Let's see. I want to move on. Yeah, another giant that I actually had the chance to talk to yesterday. This was a workshop. I get to see all these wonderful NASA workshops and answer questions myself. And then you can ask me questions. I'll try to relay. Els Peters. She's a gas. She works at the SETI Institute, and you all know what SETI means, right? Search for Extraterrestrial Intelligence. And she wants everyone to know that when you get inside the star-birth nebulas, like the Trapezium cluster, which is in Orion, just below Orion's belt, there's a nice star cluster there, and new baby stars are born. And she wants you to know that a good analogy is a roaring fire in the snow, because radiation of young stars interact with a cloud in which the stars are born, and the center of the galaxy gets super hot and influences all the other solar systems around it. Sometimes the center, see these 4 stars right here? Sometimes the center collapses and makes a black hole. If it's really, really powerful enough, it will. Or it might make a quasar, and a quasar, from what I understand, is a very powerful gamma ray factory, so to speak, because it blows a gamma ray right out of the center of that galaxy. It's a terrific amount of energy coming from here, from Orion here. All right. I want to thank the NASA Universe of Learning. These people sponsor our girl power classes, and they also do wonderful things to teach us about stars. You asked about the Eagle Nebula. Some people call it the, what did you call it? The pillars of creation. They look like pillars, but when you look at it sideways, I think you'll agree with me, it looks kind of like an eagle. Let's watch it. Both of these images were taken by the Hubble many years ago, actually. The Hubble has the ability to do a little bit of infrared, but right now we're looking at what we call the optical view. Can you see the eagle and his beak? This is the eagle's top beak and bottom beak and eye right there. And then when you switch over to infrared, what happens? The beautiful stars show up, and what was in the way was the cloud. Remember when Michelle walked through that cloud with the firemen? Infrared goes right through a lot of clouds. Clouds of gas and dust are everywhere in these star birth areas. Now, you'll notice that the very tip top of this beak, there's a lot going on there. There's some new baby stars being born. 7,000 light years away. Let's move ahead. So what does redshift and blue shift mean? Let's find out. So here's the Earth. Here's James Webb, a million miles away. And it's got its beam going out as far as it can reach. Here's a little cartoon to remind us what's happening. When the light is coming toward us, it's a blue shift. When the light is going away from us, it's a red shift. So we're going to watch in the next few images, we're going to watch for red particles in the distance and know that they are probably ancient and they are probably moving away. And the blue ones, they're probably moving towards us and they're super powerful and hot. All right, let's move ahead. So let's explore the universe with Webb. We've got some great images here, starting with the flip book of galaxies over time. Now, think about if you were looking at a galaxy today, you can see the spirals. In the center of almost every galaxy, there is a supermassive black hole. The Milky Way has a supermassive black hole, maybe even a dozen or more black holes. I've found 4 myself, not all by myself, but with the help of these giants that we're talking about. So there could be many black holes in our own galaxy. But don't worry, they're about 30,000 light years away. That's pretty far. If you want to do the math, I've got a board over there. It's 30,000 times 6 trillion. So work it out. Okay, so a galaxy that's nearby, and as they move away and away, they start to break up. They can't hold together. And all the way back in time, you probably will see something that looks like this. If you had a chance to look with a hand lens at some of these images, did you see any of those red dots? They're very small. That's what I want you to watch for tonight as we go to these images. Ready? Let's go to Stephan's quintet in Pegasus. The Hubble image is very pretty, but it doesn't have as much detail as the James Webb. Look at the background. This is James Webb. This is Hubble. This galaxy is pretty close compared to the other ones. It's about twice as close to us. Not as close as Andromeda, but it's almost close. You can see two very powerful merging galaxies. And as they swirl together, we don't know exactly what they're going to make, but we saw there's a tremendous amount of energy coming from this. So what did we say? It could be, if they come together, could be a quasar. It could develop into a black hole. Or something that we don't know what. It's possible. Let's get another shot up here and compare the deep field with the Hubble. The Hubble Ultra Deep Field is a tiny little speck of the sky, less than 1 degree. And if you put your arm out and your pinky, as far as you can reach with one eye, the end of your pinky is the amount of sky this picture came from. With 10,000 galaxies at least, and we're looking for anything that looks red. You see anything? Even if it's orange, we're getting there. But oh, I do. I see some red. So what does that mean? Those red ones are most distant, yes, and very old probably. Yes, sir. This is a simulation, a computer animation, and what they did was they took the image and they estimated what it would be like to go through yourself. So obviously the Hubble is not flying through this, but it's simulated. Let's try to get that out one more time. Thanks a lot to Frank Summers. He's a wonderful teacher. He's got a lot of video on YouTube also explaining what's going on with stars. Frank Summers. Over here we have a sample from, that's the James Webb. This is the famous constellation Volans. This is where you will find this beautiful galaxy cluster. It's so far south, I think you'd have to go to Chile or Argentina to see it. But the James Webb can point to a lot of parts of the sky. All right, so which one looks more detailed? More objects. Yeah. Okay. Of course, the James Webb has this gorgeous cluster here, but also behind it, so much more. Now, I have a couple of photographs, just prints of this galaxy cluster, and they call it SMACS. But you just have to see it at high definition on your own screen, okay? And then you should definitely put a lens, like if you got a hand lens, okay. So put it over the screen and try to find the tiniest red dots you can find. Now, right now, I want you to notice a couple of things. John Mather pointed out this one right here. You see that orange long strip? It looks like somebody is pulling string. Okay, he found out that these two are the same galaxy. They use their spectrometer and they are identical. So these two objects are one galaxy, only with the image stretched out. This is what we call the, what do we call it? The gravitational lensing. That's what we call it, yeah. And you can see a lot more of it too. There's the stretch here, here, and all around. Okay. Now, John wanted you to see there's a double group right here. Do you see these two white dots? And then go to the left of those. There's a tiny little red dot there. I don't know if you can see it, but I want you to notice that. Wait, I'm going to point to it again. Go almost straight past the double galaxy. There's a tiny little red dot there. That could be the most distant galaxy we've ever seen, counting every telescope we've ever used. It's going to be tested out with the tools that they have, and they always check it with another telescope here on Earth. The Gemini telescopes in Chile are wonderful. There's 2 telescopes down there that work great. Wouldn't it be nice to have a place like Chile where they have no clouds ever? I mean, 0 rain. Anyway, it's probably too dry anyway. I'll just say that. Okay, and right here is the close-up of what I was just talking about. Here's the pull. Go to the left, 2 white dots, and there it is. That tiny little red blob is about 13.1 billion years old and that far away. So we need to learn more about these distant galaxies. This is the spectrometry of this tiny little guy here. And we have oxygen. Can I get an intern up here to put something in the... Okay. Could you find me an oxygen tube? And we're going to try another experiment. Can you find... Hydrogen's already there. So Miranda, the one on the left, we can turn on and turn off the lights. Do you still have your glasses? How do we do it with the camera? Is the camera going to... Oh, okay. All right. Can you, Sasha's going to get, can you see what you're doing? But let's start with the one on your left. And we're going to look at the hydrogen first. Here's an example of hydrogen in this little tiny red galaxy. On the left, just flip that switch. Don't get yourself, wait a minute. Oh, you got it? Okay, good. Can everybody see that? All right, what you're looking at, can you take one step to the right, Sasha? Thank you. When you put energy through a sample of hydrogen gas, you can see with the glasses you're wearing, that type of lens tells you what we call the spectrum fingerprint for hydrogen. And hydrogen is part of water and just about everything else we need. So let's remember that. Okay, let's turn that off. Now on the screen, we also have oxygen and neon. Do you think you could find a sample of that? If you can't see well, I will come over and help you. Okay, I thought we were going to do helium next, but we're going to do, what'd you got? Okay, let's see what neon looks like. Yes, it does look like somebody's open. Okay. Neon is in the gases around this ancient galaxy, 13.1 billion light years away. Wow. Okay, so what do you see? A lot of red? A little bit of those. Okay, let's move it to another one. Can you show me an oxygen? Okay. All right. Let's put that on hold then for a minute. Turn off the neon. Good job. Could we have a light on, please? By the way, Kopernik's getting new projection and lighting in this room. I can't wait for that to happen. All right, that's cool. So we see, just like Hubble or James Webb sees through the diffraction lens to see the spectrum. And if you can find a sample of oxygen, I would love that. That would be great. All right, let's move ahead. This one I think you don't need your glasses for. It's just an amazing effect. This is what they called an extremely red quasar. A quasar in the center of a galaxy that is so energetic that it's pulling in clouds of gas around it. Now, here's what you can do. You can act like you're James Webb and notice that the first sample is blue. What does that mean? It's going toward us, right? And the last sample is red, so it's going away from us. Now, imagine in your mind, okay, this giant galaxy, which I think it's giant, but it's really far away, right? 13 billion light years. The green is a little bit blue, right? You have to use blue to make green. So that is going to go similar in the similar direction with the blue. So the yellow is related to the red just a bit, enough to make it go away from us. So if these two on the left, the blue and the green, are traveling toward us, and the yellow and red are moving away from us, what does that tell you? And they're in the center of a galaxy. They're going around in a circle. Very good. Okay, so that's what the scientists have figured out. I want to thank Christine Pulliam. She wrote back to me just to make sure we knew this was in the constellation Hercules. So it's in our neighborhood. It's just 13 billion light years away, so it's too far to see, even with a really good Kopernik telescope. But the James Webb is going to be exploring this, what they call an extremely red quasar. And I hope that there's no extremely great gamma ray bursts coming out of that. That's a concern. Okay, that was pretty neat. Did you find any oxygen? Well, a galaxy, sorry. Oh, what'd you find out? Yeah, all stars are, and galaxies are, yes. But that gas, that particular mass, what's it called? Gamma rays, yeah. Those are powerful enough to blow away your atmosphere for the whole planet, and probably the liquids too. Yeah, so we don't want that anywhere near us, right? Okay. You can't exactly move the planet, so we have to keep our eyes open for things like that. But it's so far away, we don't have to worry. You can see this word toward and away. I just realized that was down there, and that was the answer. Gave it away to you. Okay. One of the most beautiful images in the Carina Nebula was taken partially by the Hubble Space Telescope. But notice how many more stars we can get with the James Webb. This cloud, scientists tell me that they're still studying this very closely, and they're all taking a little piece, like a lump here and a hole here and a star here. They're all doing different things. Some places have new baby stars being born. Others have stars that are dying. So it generally, you could say, the blue stars will be new baby stars, and the red ones will be dying stars, but not always. But aren't they gorgeous? All right. And I know you caught a glimpse of this earlier with Dr. Mather. But I found out that the near infrared will show you the top layer of this planetary nebula. This is called the Southern Ring Nebula, and this is where a star died right here. And you can see one star with 6 spikes. That's the James Webb signature. And you can see layers and layers of gases and dust and radiation, your favorite, coming off. They call it a planetary nebula because it looks like a planet, but we all know it's a star that's dying. Now, this is the same one, only taken with a mid-infrared image, so this means it's going through part of that round bulbous nebula. And because we're looking through it, we can see inside. There isn't one star. How many are there? There's two, right? And because of that, scientists are really curious about this. Why would there be two stars in one planetary nebula? It's something to look further. Yeah. Oh, could this star be on the other side? Yeah. Yeah, see this one right here? We're not really sure if it is inside or not. That's a really good point. I'll bet a lot of questions like that are coming up in all the scientists' laboratories. Something that's neato to me is this thing. Shoo, shoo. It looks like a very fast-moving something is going right out there into space. Maybe it's a gamma ray burst. I really doubt it, though, because planetary nebulas don't usually have enough energy for that. But this is a place we are studying for the first time, so it's possible. I think it's kind of neat that the southern people have a flying fish for a constellation. So, did you know that the Earth's atmosphere is made up of these things? Well, just a little bit too much carbon dioxide for me. But anyway, it's very interesting to learn other planets are very similar to ours. But this one, not so similar, even though it's loaded with what? H2O all over the place. This planet goes around its star every 3 days. 3 days. What does that tell you? It's really close to the star. Yes, it's so close that the temperature is over 350 degrees. So, yeah, not a good place to go visit. No. Interesting, though. It's called WASP 96. And it's really big. And these are the people arriving for the 8 o'clock show, which we don't have. Okay. Now, I would like you to compare another interesting dot, and this is probably the last one. Let's see. Yeah. Okay. They zoomed in on two little dots. They call them number 1 and number 2. And it says, 2 of the farthest galaxies seen to date are captured in this James Webb telescope picture. And take a look at number 1. Can you see a little tiny dot there? Okay. This is a different place. This is called Abell. Abell has a lot of great stuff, tons of galaxies. Very fascinating place. And number 2, let's find that. It looks like a clump, 2 clumps, maybe 3 clumps of gas. But there's a red dot right in the middle. And we all know that red dots usually mean very, very distant and very, very old. Very old. Okay, so we are studying these two, and this is what I meant when I said we're drawing back the curtain to see behind all these galaxies what's going on beyond that. And you're going to have to use the best tools you can to stretch this out. Maybe you have the ability at home to zoom in on some of these images. I'm going to give you a website. Flickr has a wonderful Hubble telescope image. Let's see if this is going to work for me. Nope. Okay. It's right here. Where's my Flickr? There it is, right? Okay. Ah, found it. Thank you, Jeremy. Okay, this is the James Webb Space Telescope catalog. Hi. And one of the things they found recently, Titan, new pictures from Titan, one of the moons. Okay. Around Saturn. And, oh, I love this one. It's another Eagle Nebula, but this time it's loaded with fuzz. And that's if you use a different camera, near infrared. And this one, apparently the vice president had a visit with the president of France, and they looked at this one together because the European Space Agency is helping us with the James Webb. It looks like I could probably get that bigger. Let's see. There we go. One more click. There we go. Can you see two galaxies? Yeah. They're merging together. Tremendous amount of energy there. That's Hubble and that's Webb. Lot of energy. Two galaxies together could really make a gigantic amount of energy. Okay. Let's see. How do I get out of this? Jeremy, can I just click on it? I don't need to go back. I'm not used to this particular flicker. Okay, thank you. All right, let's go back to our site. There we go. So, yeah, you got it. You can always go to webtelescope.org, but sometimes you get caught up in the mechanics of the machines and not the images. So you can put images in your Google hunting. Put the word images in the Google hunt if you're hunting. Yeah, maybe you could do a project on your own to show that you found the deepest, darkest, most distant star or galaxy. All right. Oh, this is the story that I meant to tell you. This one has, see the red on his lip? That's a place where new baby stars are being born. And from what I understand, stars need about 25 million degrees Fahrenheit to light up. The fusion doesn't happen unless it's very, very hot. So these are very, very hot places. Right here and right down here. Okay. It talks in this article about President Emmanuel Macron visiting with Vice President Kamala Harris. And they both had a great time looking at these images. Now, I'm going to switch over to the moon for just a bit. But if there are any questions about the James Webb, I'll try my best to answer them after this. Okay? People have been asking for an update on the moon. And as I was walking in the door here tonight, NASA sent me more information, and there was a press conference this week. I didn't catch all of it, but if anyone in this room wants to add to it, please do. First of all, this is the target where we hope to land and build a colony. Can you see a perfectly round crater right in the middle? This is called Shackleton Crater, named for Ernest Shackleton, the guy that explored the South Pole of the Earth. Well, this is on the South Pole of the moon. And we like it because, look at it, it's always lit up. There are 14 days of daytime and 14 days of nighttime on the moon. But if you're right there at the very, very bottom, there's always a little bit of that crater lit up all year long. All day, all night. So what could you do with that much energy? There's no clouds. It's absolutely beautiful for making solar energy, yes. So the idea is to find a place to settle in, build a couple of habitats with your 3D printer. Maybe. Ask Jeremy about 3D printers. He knows how they work. And we're going to find a spot where you can land, maybe over here. Okay, let's go on. So Artemis wants you to know that when you go to the space station in low Earth orbit, you can get home in 3 hours. You break your leg or you get sick, you can get home in 3 hours. It's traveling 17,500 miles per hour, and it's about 250 miles up over the Earth. If you want to go to the moon, it takes about 3 days. So yeah, you could get home in 3 days. So that's pretty safe. This is how hot it is when you're coming home, going through the atmosphere of the Earth. Your heat shield's got to be able to handle that much temperature, 5,200 degrees. You're traveling at 24,000 miles an hour, and it's about 240,000 miles to the moon, average. But going to Mars is another story. You have to first wait for Mars to come to this side of the sun. And when it does, it takes about 9 months to get there. So you have to wait 2 years for the planet to come over to this side, then another 9 months to get there. So you can't, order a pizza and expect it to be on time. At 6,000 degrees, it takes to go through the Earth's atmosphere when you come home. I don't think you'd have to worry too much about Mars' atmosphere. It's pretty thin, but it is hard to slow down. And the distance to Mars when it's close, 39 million miles. Okay, and that's one of the closest planets, right? All right, so Jeremy's going to tell you how you can get one of these capsules from Kopernik, not the life-size one, but the miniature version of the Orion capsule. We really love the guys and girls over at Lockheed Martin in Owego. They are making, or already did make, the software and some of the screens on the Orion capsule. That was great. So that's what's traveling. But this trip is just a couple of mannequins traveling on this spacecraft. And they're right inside here. And my grandson wanted everybody to know that this is him down there. And this is his giraffe. Okay. So there's another spacecraft that's being built right now. It's very similar, you can see. But it has an extra chunk for cargo. And the cargo will hopefully include a vehicle and a house. So you can live in that while they're building the rest of the habitats. Of course, you might recognize the Saturn V from the Apollo days. Very close. Look, it's only 1 foot shorter. Wow. Well, they tell me, and I believe them, that the Orion is more powerful than any of these. It wins. Especially the big one, the Max. It's got to have a lot of boost to get off of this planet. And these are the nice people who are in line for the job of being the first ones on the moon. We're not going to let everybody go. There will be 1 woman and 1 man. That's not true. There could be two men or 2 women. But some of them will be color, brown-skinned people, and some of them will be female. And we hope they win the prize. I think the last time I checked, Orion can hold 4 people. It might be bigger this time. I don't think so. Anybody know? I think it can hold 4 people. And there's a tiny little bathroom, but not very great. And this is my ticket. I already have, I'm actually on the moon right now, waving to everybody. This is a hologram of Tish right here. So yeah, I got my ticket years ago, back when they were still building it. So it's a great thing. I'm very proud of NASA. Question? Oh. What guys were that? And where was I? Do you remember what year that was? Anybody? Oh, I'm so sorry I missed it. Oh. Well, we have some local astronauts that are straight that way. You'll see their pictures, and we're very proud of them, but none of them are going to the moon. They're all retired now, except for Jeanette Epps from Syracuse, and she didn't sign a flag, but we'll keep our eyes open for that story. Will you look it up for us, Dave? Mark? Would you? I'd love to see it. Well, let's continue. I'm almost done. The Gateway International, NASA has decided that we need a space station to be an interim between the Earth and the moon. Now, even though SpaceX, see, I'm wearing a SpaceX shirt today. SpaceX has some beautiful rockets, and they do land vertically, successfully, hundreds of times. We're just not really that sure that you're going to put people in that rocket and you're going to land on the moon without tipping over, okay? So, just to be on the safe side, people will stop at this space station. And you see all these docking ports? 1, 2, 3, 4, 5, at least 5 docking ports, places where people can park, get out, stretch, have a little snack, and go down to the moon from there. Because there are small vehicles that can go down there and that don't have all the fuel in them and all that. It's much safer that way. And we all want you to know that the people that are in, let's say, middle school right now will be just the right age to go to Artemis Base Camp, and it will be a chance for you about 20 years from now to learn from the best. And you're going to live right there at that crater with all the sunshine, but it's freezing cold, okay? And in the sunshine, it's plus 200 degrees. In the shade, it's minus 200. And at the bottom of the crater, it's minus 400 degrees Fahrenheit. Okay. Isn't this a great idea, though, having these lights all around? If they put lights all around, we could probably see it from, oh no, we never see the bottom of the moon, do we? Jeremy, do we ever see the bottom of the moon? No. Not from here. Not going to do it. You're going to have to be on a rocket to see that, sorry. It's interesting to think about, though. Yeah, I don't think anybody's going to turn the moon around so we can look at it. Mm-hmm. Oh, okay. When it does one of those wobbles. Yeah, we'll try that. And then Artemis 3 is going to be a treasure trove because we're pretty sure that in every bit of rock there are titanium, platinum, oxygen molecules. There's all kinds of wonderful treasure that you can get out of the moon. Just be really careful. You can't breathe the air. Where's Artemis now? Let me see if I can get this. Oh, that's really bright.
I'm Dr. Jeff Inniker, and today we'll explore the phases of the moon.
Yike. I'm not sure I want this. I'm going to move ahead to where they are now, right here.
Along our path, we've made it to the moon, and now we're about to dip in as close.
Okay, it's on its way back from the moon. Right about halfway, you can see that. That's not real. That's an what is that? Graphic. Thank you. All right. All right, where am I? Uh-oh. I pushed the wrong button. Anyway, you're welcome to check it out. And I went to the NASA channel, and they were sleeping at the switch.
This program, I'm going to walk you through really quick what it's going to
So I'm
look
sorry,
like
that
going around
happens
the moon
occasionally.
and then coming home back to Earth at the end.
There we go.
So at this point, we've gone along our path, we've made it to the moon, and now we're about to dip in as close as we'll get for the entire mission on this outbound powered flyby. Now this burn, it's largely going to be using that orbital maneuvering system engine, that large one that we tested out on earlier burns. And it's also going to be using the auxiliary thrusters. We've got some reaction control ones to help control our attitude. But what this is really designed to do is to get us around the moon and start heading into distant retrograde orbit, or DRO. That's this dotted line that you can see up here. This is really where we're going to learn about Orion while we fly around the moon, about 38,000 miles off the lunar surface. And we call it retrograde as the moon is heading in that direction. Orion will be heading in this one, opposite retrograde. Now, after we're done in that orbit, it'll be time to...
That's good. There are lots and lots of places who are saying that they know where Artemis is right now, but you can't believe it unless it's a NASA article, please. Yes. It already did one, and now it's going to do one more that's really close, and then it comes home. That's what I bet they would do an extra one, though, if they thought they could learn from it. Remember, the dummies in the capsule are loaded with sensors, and they're trying to figure out all the possibilities of what could happen. You found it? So who was that?
That would have been October of 2019,
Was that during COVID?
just before. They say they were taking this flag all over the place, this guy and another guy,
All right.
and letting people sign it, and they're going to take it to the moon. That's the idea, is that this flag is going to go to the moon, and they're going to place it on the moon.
Okay. Would you please tell everybody about that? Can you do that?
Well, it's just that a couple years back, we had some people from NASA here, and they had this flag, and they're going to take the flag to the moon. Well, I don't need to be on spotlight, but okay.
So, he's got a picture of the flag. And Mark is here a lot.
Right. So this flag here, I don't know if you can see it or not, but they're going to take that flag to the moon and place it and leave it on the moon. And they're taking it all over the world and letting people sign it.
All right, thank you. Well, can we find out the person's name? All right. Because I can get a hold of somebody down there and find out if they've got a flag that we signed.
But if you check through the records, okay, check that date, because that's the date that they were here.
Uh-huh.
We must have a log on who was here and who presenting,
Oh, yeah, sure.
So that's how you can find out.
All right, we're going to try that. Okay, cool. Thank you, Mark. I want to end with how very proud we are that we are working on these 5 hazards of human spaceflight. Jeremy and I and several other instructors here at Kopernik, we are putting together a project for some local students, and we're going to teach them how they can survive space radiation, isolation, distance from Earth, gravity, and hostile environments. There are a lot of hostile environments. So watch for us to come to your school, or possibly you could watch us on YouTube. We'll watch and see how that works out. Watch for us next year. And I thought that you might recognize this guy's voice.
It's a sultry night in July. You've fallen asleep in the armchair. Abruptly, you startle awake, disoriented. The television set is on.
Does anybody
not the
recognize
sound.
this voice?
You strain to understand what you're seeing. Two ghostly white figures in coveralls and helmets
He's
are
dreaming
softly
about
dancing under a pitch-black sky.
how wonderful it was in
They
1969
make
when the
strange
first
little
people
skipping
stepped on the
motions,
moon.
which propel them upward amid barely
You can find
perceptible
this
clouds of
also
dust.
on YouTube. I guess it's a good
But
commercial for
something's wrong.
YouTube.
They take too long to come down. Encumbered as they are, they seem to be flying. A little. You rub your eyes, but the dreamlike tableau persists. Of all the events surrounding Apollo 11's landing on the moon on July 20th, 1969, my most vivid recollection is its unreal quality. Neil Armstrong and Buzz Aldrin shuffled along the gray, dusty lunar surface, the Earth looming large in their sky, while Michael Collins, now the moon's own moon, orbited above them in lonely vigil.
And being in my 70s, you know, it was amazing to be there at that time, to watch this on TV. And if any of you remember it, it's been over 50 years. Isn't it time to go? Think of all the treasures we can come back with and take care of the Earth at the same time. So we have some very brave people who can't wait to go to the moon. And let's cheer them on, okay? All right, thanks a lot for coming tonight, guys.
You can keep those. With the gateway, will they have to take that up in parts like they did the space station? So it's gonna be a very time-intensive thing to.
Grumman, Northrop, they're working on pieces, but also Italy's making a piece because they made one for the space station. So we're working together with the same people, the European Space Agency. But you know what's really weird is some of it was made in the UK.
Yeah, I mean, we definitely can go back and look and see who it was.
So they're going to have to come up with something brilliant. And it really, you really only need
Yeah,
what?
we'll see if I go. It's before we started streaming, so you can't look on that or on those records, but you can see.
There was two guys, there was him and another guy.
Okay.
And they brought that
So,
flag,
You
and
know,
said,
there's no error.
They have, I'm sure they have a timetable as far as when they want to begin and how long it
They're
might take.
not.
sign it again. That's all
Oh,
it takes.
okay.
But you know, Artemis 2 doesn't require the space
They
station.
said that.
They're just going to go on the same route again, and then go around a couple times and come back. Just to see if everything works okay and everybody's all
My
right.
signature will be on the moon.
Then, so that's another 2 years.
Right. No, that's very cool.
26.
If things go on schedule then.
They promised in this decade. Is that possible? But I think that third one, Artemis 3, is going to have the habitats already there.
Yeah, that was a good
And there's a lot of clamor for, you know, all the different companies like